Okay. Okay. You don't have any questions. Okay. So this is not final, Adiva. This is the first equation. Take a look. This is for the first equation for the ferrum. And then this is the second equation for MnO4. So let's combine together. Yeah, I will rewrite again. Yeah, Mn, we have to copy it, yeah. MnO4 negative plus 8H positive plus 5E electrons become Mn2 plus 4H2O. And then we have to copy this equation also. 5 Fe2 plus become 5 Fe3 plus 5 electron. And then we add it together. So we combine it together, yeah. We copy, we move down this O4 negative. Plus 8 H positive. And then what else? For this part, plus with 5 Fe2 plus. Don't forget, because this is the same. Take a look. This is the same. 5 electrons on the left and 5 electrons on the right. So you may cross it because the same. Yeah. So become Mn2 plus with 5 Fe3 plus plus again with 4 H2O. This is the final balance equation of redox. This is for the final answer. Any questions, Adiva? If you have any questions, you can ask me. Okay, please, like you have to analyze what step that you miss it. What step that you really, really don't understand, you can ask
me. Maybe the one starting from the 5Fe2 plus 5Fe3 plus.
Huh?
The one on top.
I cannot hear your voice clearly.
Maybe starting from the equation on the very top.
On the top, in the first equation.
Yeah,
Or start from the ferrum.
the one with 10 and 15.
Oh, the chart 10 and 15.
Yeah.
Oh,
Yeah.
okay. Yeah, okay. Okay, wait, yeah. Maybe I will re-explain again. Take a look. Wait, yeah. I will erase again. The first step, Fe2 plus. Kan? Nah, ini Fe2 plus become Fe3 plus. This is unbalanced because the charge on the left is 2 and the charge on the right is 3. So to make it balanced, we have to plus electrons on the right because the charge of the electron is -1. Yeah, so 3 minus 1 is 2. Both the same. And then next step. Yeah, the number of the electrons lost in oxidation must equal the number electrons in the reduction. Take a look. This is reduction. How many electrons, Adiva? This is 5 electrons. Okay. So, because this is 5 electrons, so this is also will be the same. Of course, 5 electrons. So you have to times 5 on here to make it the same. This is 5 electrons. I will sign it. This is also 5 electrons. Understand? So both, yeah, the equation I will times with 5. This is times with 5. This is times with 5. This is times also with 5. Both. So let's check it again for the charge. 5 times with 2 is 10 on the left. And then on the right, 5 times 3 is 15. This is negative. 5 times -1 plus -5. Balance 10 equals 15 minus 5 also 10. This is the charge also balance. So you understand, yeah, why we times with 5? Because we have the same coefficient. This is 5, this is 5, this is 5. The same also with this 5. Understand, Adifa? Any questions?
No.
So, this is 5 electrons. This is also 5 electrons, so we can eliminate it. If it is not the same, we cannot eliminate it. Yeah, this is the characteristic how to make it the balance equation. Okay, nice. Next, yeah. Okay, copper oxide, CuO, reacts with ammonia and H3 to form copper, nitrogen, and also waters. So we have to identify what is the reactants and also what is the products. Of course, the reactant is copper oxide. Yeah, this is for the reactant. This is, we call it reactant. And then what is the products? The products is copper, nitrogen, and also the water. Copper, nitrogen, and the water. This is, we call it products. So we have to write down, yeah, CuO plus NH3 become Cu, ya, copper is tembaga in bahasa, plus with N2 plus with water. Okay, the first step, we have to analyze oxidation states. Take a look for Cu. Okay, do you still remember what is the Bilox number for oxygen? The Bilox number for oxygen is -2. Always, sir? Yes, always. So, of course, for Cu is negative 2 or positive 2 po? Positive 2.
Wait, what does
Yeah.
Bilox the number name
Yeah.
again?
Bilox number, yeah.
Okay.
Bilox numbers is the numbers in each atoms. Yeah,
Oh, can
that's
you
will be determine how it can become oxidized if it meets with another atoms.
write the
Yeah.
spelling?
Huh?
Write the spelling.
The spelling.
Yeah, of the Bilox number.
Oh, the notes. Negative 2,
Yeah.
it's mean Bilox. Oh, okay, yeah. This is the Bilox
Oh, okay, okay.
number, yeah, of oxygen. Yeah, always sir, yes. Ah. And
Okay.
then Cu, of course, positive to y, sir, because to make it balance, yeah, the charge of CuO is 0. So, to make it balance, positive 2 ya. Karena positive 2 minus 2 become 0. Yeah, so this is positive 2 and then meets negative 2 become 0. And then for nitrogen, yeah,
Mm.
how to know, sir, take a look, yeah, for hydrogen is 1, always 1, sir, yes. So, the Bilox number for hydrogen is 1. So 1 times 3, of course 3. Yeah, so
Mm.
we can write down, yeah, this is kan the Bilox number. Bilox number of hydrogen is 1. Because this is 3, of course 3 times 1 is 3. Yeah, negative 3. So the nitrogen, of course, negative 3 ya.
Mm.
To make it balance ya, karena negative 3 plus 3 become 0. Okay, understand ya? Okay,
Mm.
take a look. This is the changing. This is kan the first nitrogen negative 3. Take a look on the right. Nitrogens is 0. Why 0? Because this is atoms, not substances, yeah? So if it is atoms, not substances, so the Bilox number is 0. Yeah, this is start from negative 3 and then decrease become or increase ya, start from negative 3 up to 0. Because this is increase, we call it oxidation.
Mm.
Yeah, why oxidation, sir? Because the number of the Bilox is rise or increase. Start from negative 3 up to 0. And how about for copper, sir? Take a look. This is Cu. Cu also 0. Why 0, sir? Yeah, if it is atoms, yeah, not substances, the Bilox number also 0. Take a look, yeah. This is start from -2. Become 0. -2 becomes 0. So this is reduce. So if it is reduced, we call it reduction. So copper reduction and nitrogen oxidation. This is the basic concept how to distinguish what is oxidation and reduction. Okay, Adifa, any questions?
Mm,
Mm-hmm.
mm. Can you give another example?
Another example for
Like this,
for
so
oh
like I
like
can
this. Oh,
understand.
another,
Yeah,
yeah,
yeah, yeah,
another questions.
yeah, yeah. So
And
I can
this is
understand
not,
it more.
this is not final.
Oh, oh, okay, okay.
Yeah, this is not final answer. I will explain again, but I follow up you up to this step because the step is too much. There is
Oh, okay,
there is next step.
okay, okay.
Okay, understand? Yeah, I will continue again.
Mm.
So, okay, you are now in grade 11, right? So what capture that you learn in your school, or this is the beginning? No, I mean like in your school, your teacher has give you the capture, the topic
Oh,
for chemistry.
it's only atomic structure. Um, up to now because we only started school.
Oh, you never started in your school. Oh,
Yeah.
okay, in grade 10, have you learned chemistry
Oh,
before?
yeah.
Okay, good. Ya udah. Okay, okay. Nice. Okay, I will continue again, ya. Next step, this is about the Bilox number. So we have to make it balanced for the nitrogen because this is not balanced. Okay, I will rewrite again. CuO plus NH3 become Cu plus N2 plus H2O. This is 2. So you can write down 2 to make it balanced. Understand? This is N2. This is 2N. So the nitrogen is 2. Okay. Next step, we have to balance for hydrogen. Take a look. How many hydrogen? On the left, take a look on the left. Ah, 3 hydrogen. But on the right, only 2 hydrogen. Not the same. So, but be careful because the coefficient is 2, diva. So 2 you have 2 times with 3. Yeah, 2 times with 3 is 6. Yeah, so 2 times with 3 is 6. 6 hydrogen on the left. Okay, so on the right only 2. So to make it balance, you have to times with 3. So become the same. 3 times with 2 is 6. 6 hydrogen on the right. Okay, you get it,
Mm,
Adifa? To
yeah.
make it balance for nitrogen and hydrogen, to make it equals.
Yeah.
Yeah, understand, yeah? Okay, next. We have to balance also for copper and also for oxygen. Take a look for oxygen on the right. On the right, the oxygen is 3. How we know, sir? 3 times 1 is 3. Yeah, there are 3 oxygen on the right. But oxygen on the left, only 1, not balanced. So to make it balance, you have to write down 3 on the left. So become balanced. 3 times 1 is 3. Okay, so there are 3 oxygen on the left. Okay, you get it? Any questions, Adiva?
No.
No? No?
No.
Mhm.
Mm.
Okay, so take a look once again. We have to make it balanced for copper. How many atoms of the copper on the left? Because there is 3. 3 times 1 is 3. Yeah, so 3 copper on the left. Yeah, 3 times 1 is 3. But on the right, only 1. Not balanced, sir. So to make it balanced, you have to times with 3. So there are 3 copper on the right. Okay, all of it balanced. Copper, yeah, I will make it the conclusion. For copper, 3 on the left, 3 on the right. 3 oxygen on the left, 3 oxygen on the right. 6 hydrogen on the left, 6 hydrogen on the right. All of it is balanced. Okay, this is the basic chemistry. That will be redox also, and also about stoichiometry. This is the basic concept that you have to understand in the beginning of chemistry to make it the balance equation. This is
Mm.
also relate how to calculate pH. You know pH, yeah, in the capture acid and bases. Okay, I want to ask you, have you learned it about how to calculate pH? A pH for acid and base and also salt?
Can you show one example?
For example, like, yeah, just like how to find out the pH of HCl. If it is the molarity, for example, 0.1 molar, something like that.
Or like stoichiometry?
Like that. Or yeah, Diva, if you get an PDF book, soft file book, I mean, from your school, you can share to me. Or maybe you can share admin IB privates, so admin can share to me. Or maybe if you don't have it, maybe like the PowerPoint or Canva, the material that you have got from your teachers in your school, you can share to me also. Yeah.
Mm, I
Do you
do
have
have
it?
I do have
Huh?
an online book, but you have to log into my account. I can't share it outside.
Okay, maybe next, yeah. Mm-mm. Okay, okay, I got it. Okay, it's okay. I know that to learn chemistry, it's step by step. I think it's cannot if in the first meeting you really understand 100%. Step by step. Yeah, maybe if you repeat again for the next example, and then you learn by yourself and continuously, I think you can understand. Okay, Adiva, maybe in the university, what major that you want to enter? Maybe, for example, like chemical engineering or medical science. I mean, doctor or what?
Either medical science or food technology.
Oh, food technology. I think food technology or medical science is related with biology and chemistry.
Mm.
Okay, and also pharmacy also like that. Okay, okay. Um, wait for a while. Okay, I will. This is how to calculate pH. Wait, yeah. Okay, no questions, yeah. Maybe I will share my notes after the class. Okay, if you don't any questions, I will continue for next questions. I mean like this, how to calculate the pH. Ah,
Oh, I don't think I have any questions like this yet.
uh-uh. Oh yeah, I think yeah, our goals to do the course, yeah, we
Mm.
have to learn, yeah, we have to learn faster from the school. For example, yeah, if, for example, like about acid and base, if you haven't got it from your school, so you have to learn it first in the course.
Mm. Okay.
In order that when you in the school, you really understand and accept the concept really, really easy. Yeah.
Mm.
Okay. Okay. It's okay if you don't understand. I will guide you how to understand the concept first. Remember this, yeah. Calculate the value of Ka for methanoic acid. A solution is 0.01 mole decimeters to the power of -3. That's, we call it molarity. Ah, this is the concept of molarity. What is molarity, sir? This is related to stoichiometry. Molarity, that's mean the mole divided by the volume. But be careful, the units of the volume is on liters or decimeter cube. If it is the units meter cube, you have to convert it into liters. Yeah,
Mm.
methanoic acid. Ah. And then the pH is 2.9. Be careful. pH, it starts from 0 up to 14. Yeah, if it is 0 up to 7, we can group it as a acid. Yeah, okay, I will continue.
Hello?
But if it is, yeah, okay, hello, yeah. But if it is 7 up to 14, we can group it on bases. Okay, yeah, I will give you the concept. Methanoic acid, we group it as a weak acid. Why, sir? Because we know Ka. Yeah, so um, HCOOH, you have to memorize it. We group it as a weak acid. Yeah,
Mm.
take a look. HCOOH. Ah, H plus, plus with HCOO negative. Nah, take a look, Diva. The presence of H plus, this is based on the Arrhenius theory. This is acid. So if there is the presence of H plus, that solution become acid. That is the characteristic. So how to calculate pH, sir? Yeah, this is the formula. Yeah, relate to mathematics. To find out pH of the solution is equals negative logarithms of the concentration of H positive. Yeah, this is the first formula. And then to find out H positive equals 10 to the power of negative pH. Okay, yeah. Okay, this is the basic theory first. Okay, I will explain, yeah, if you don't if you don't have any questions. Now, take a look. We know that the value of pH is 2.9. Of course, the first step, we can calculate what is the concentration of H plus. The concentration of it 10 to the power of negative pH equals 10 to the power of negative 2.9 because the pH is 2.9. Understand, Diva? Any questions? No?
No.
No. Okay, I will continue. Maybe you can use calculators, yeah? So to find out the concentration of H positive is 1.25 times 10 to the power of negative 3. Don't forget the units of the concentration is molar. Molarity. This is the first step. Okay. And then next step. Yeah. Take a look. HCOOH. Yeah. It can be dissociation equation become H positive plus HCOO negative. So if the concentration for H plus is 1.25 times 10 to the power of negative 3. This is also will be the same. 1.25 times 10 to the power of negative 3 also. Because the coefficient is the same. This is 1. This is also 1. So the concentration also will be the same. Understand, Diva? Any questions?
Is 1.25 times negative 3 a constant?
Yeah.
Oh, okay.
This is from this. Yeah. We know it. Yeah. Okay.
So I have to memorize it?
Yeah, the
Okay.
formula. Of
Okay,
course.
okay.
Yeah, this is and then also there also a formula again. Yeah. Next next step, yeah. Take a look. To find out Ka, the formula is the concentration of H plus times with the concentration of HCOO negative and then divided by the concentration of HCOOH. Ya, on the right, take a look here. This is kan on the right nih. You have to produce it. Yeah, you have to multiply it as a numerator. And then after that, you have to divide it by this. As the denominator is the reactant. This is the formula. How to calculate Ka. Yeah, this is also, okay, sure. Should I memorize this? Yes, of course. Yeah. So after that, you just substitute the values. The concentration of H plus is 1.25 times 10 to the power of negative 3 times again with 1.25 times 10 to the power of negative 3 and then divided by, okay, what is the concentration of HCOOH, sir? You know, in these questions, 0.001 of methanoic acid. So you write down on here, 0.01. Do you have calculators, Diva? Do you want to try? Maybe you can calculate, but you have to use calculators. What is the answer? You can tell to me.
Okay.
1
1.56
point.
times 10 negative 4.
Yeah, 1.58 times 10 to the power of negative 4 molar. This is the final answer. Okay. So how many formulas, sir? This is the first formula. And then this is also the second formula. So you have to memorize it. Any questions? Adiva?
No.
No, yeah. Okay. Yes. Next questions. This is about electrolysis. This is Ag. What is Ag? Ag is silver. Yeah, argentum in Latin language. Copper, cobalt, I mean copper, Pb and Zn. Take a look the questions. Which metals in the list is the best reducing agent? Okay, I will give you the theory first, yeah. Okay, standard, we call it standard electrode potential. Standard electrode potential. E0. Yeah. What is it, the concept? The concept is the measures the tendency of a chemical species to acquire electrons. Yeah. Be reduced relative to the standard hydrogen electrode. Okay. For if it is more positive, if it is more positive, if it is A0 values, I mean, if it is positive, indicates a greater tendency to undergo reduction. Yeah, it gain electrons. The species acts as a strong oxidizing agent. And how about if it is more negative, sir? If it is A0 values, it is indicates a greater tendency oxidation to lose electrons.
Mr. Can I go to the toilet for a bit?
Oh yeah, okay, please. I will also fill my waters. Okay, okay.
Okay.
You can ask me if you have done, yeah?
Hello?
Yeah, hello. Okay, next, yeah.
Mm.
Indicates a greater tendency oxidation. That's mean the loss of the electrons. Yeah, so don't forget the species acts as a strong reducing agent. Uh, this is, we call it reducing agents. Yeah, so if it is negative, lose electrons, but if it is positive, gain electrons. This is oxidation agent. This is the basic concept. Okay, next, yeah. This is the theory first. Okay, what is reducing agent versus oxidation agent? What is the differences, sir? For a reducing agents, that's mean gets oxidized itself by donating electrons in a list of reduction potential. The strongest reducing agent is found on the right hand of the half equation with most negative standard electrode potential. And what about an oxidation agent, sir? An oxidizing agent gets reduced itself by what, sir? By accepting electrons. The strongest oxidizing agents has the most positive standard electrode potential. Okay, so what is the reactivity of the metal? Yeah, so the metal react by losing electron to form positive ions. Okay, yeah, back to the questions. That's all the basic theory. Back again in this. What is the most negative? Start from this. 1, 2, 3, 4, 5. Okay, Adiva. Which one is the most negative? I mean like the smallest number. The most negative. Which one? Diva.
Mm,
It's okay if your answer is wrong, doesn't matters.
zinc 2 plus.
Yeah, yeah. Yes, of course, zinc. Because this is negative 0.76. The most negative, the smallest number. So because the most negative value is negative 0.76, so the answer is zinc. Zn. Why the reason? Because the best reducing agent is the most negative value. Yeah, I will give you the explanation for number A. A reducing agent is oxidized in a reactions for metal with the most negative electrode potential. Lose electrons most readily. Yeah, so the best is zinc, the most negative. Okay, and then for number B, which metal ion in the list most difficult to reduce? The clue is has the lowest most negative reduction potential. It requires the most energy negative potential to force reduction to make the most difficult ion. Which metal ion? The same, yeah. The most difficult to reduce is Zn to positive. Because this is also the most negative. It means difficult to reduce. Yeah, so the concept is reduction is the gain of electrons. The more negative the electrode potential, the harder it is for that ion to accept electrons and to form the metal. Yeah, this is the basic concept. Okay. If you have any question, you can ask me, yeah, Diva, yeah.
Mm.
Mm-hmm. For number C, which metal in the list is most reactive? The same also, yeah, the metal reactive metal reactivity depends on how, this is the basic theory, yeah, how easily the metal atom can be oxidized. It's mean to lose electrons to form ion. Take a look. Zinc has the lowest standard reduction potential, negative 0.76, meaning its reverse reaction has the highest positive oxidation potential. Thus, zinc loses electrons more readily than any other metal on the list. So the metal is zinc, Zn. Yeah, this is also theory because chemistry combined with theory and also calculation. Yeah, and then for number D, which metals ion in the list is the easiest to reduce? Yeah, an ion that is easy to reduce has a high affinity for electron corresponding to the highest. For the most positive standard potential. If you analyze it, the most positive value, of course, is positive 0.8. It is for argentum Ag. Yeah, so the most positive value is positive 0.8 for silver ion. Okay, any questions? Diva?
Not yet.
Not yet, yeah. Okay, it's okay. Okay, if not yet, I will continue again. This is ini ya, sir. Teori ya. Should I memorize this? Yes. Okay. A learner passes a constant electric current of 0.15 through a solution of silver nitrate using pure silver electrodes for 45 minutes exactly. The mass of the anode decreased by 0.45 grams. Use this data to calculate the charge on the mole of the electrons. Okay, I will give you the basic theory first, yeah. Okay, electrolysis and the Faraday law. Yeah, at the anode, electrolysis, and Faraday law. Okay, at the anode, silver atom lose electrons to form silver ions in this solution. Take a look ya. Ag is perak in bahasa. Ag become Ag plus aqueous that's mean larutan, and then plus with electrons. Why, sir? Because this is kan positive and then negative become neutral. What is mean, sir? It's mean for 1 mole of electron is transferred for every 1 mole of silver atoms. Silver atoms dissolve from the anode. So next step, electrical charge. What is electrical charge? Electrical charge is Q. The total electric charge, yeah, this is the concept first, yeah. What is electric charge, sir? The total electric charge passed through the circuit is the product of current I and time t in second. Q equals I times t. Don't forget to find out the mole, yeah, in stoichiometry. Mole is mass, yeah, divided by AR. What is AR, sir? AR is relative atomic mass. Okay, this is my explanation about the basic theory first. Okay, yeah, back again in these questions. A learner passed a constant electric current. So we know the data, the current I equals 0.15 ampere. What is the time? The time is T equals 45 minutes. If you want to change into second, is 45 times with 60 seconds equals 2,700 seconds. So we can use the formula to find out Q equals I times with T. Yeah, this is the formula. You have to memorize it. Okay, so equals, because we know the data, the current is 0.15. So 0.15 ampere times with 200 and 2700 second. So you can calculate with your calculators. The result is 405 coulomb. Don't forget, the units is coulomb. Any questions, Diva?
No.
No, yeah. Okay, next. Next step, we have to calculate the moles of the silver. Yeah. Okay. We know that the mass is 0.44. Yeah, so the mass is 0.45 gram. So the relative atomic mass for AR is 108 gram over mole. Of course, yeah, this is the data. This is related to stoichiometry, yeah. Okay, have you learned stoichiometry before, Diva?
Yeah.
Yeah. So to find out mole, this is stoichiometry formula. Mass divided by atomic mass number. So 0.45 gram divided by 108 gram over mole. So you can divide it. The answer is 0.0041 mole. Now, can you understand?
Mm.
Okay. Okay, next step. To calculate the charge of the mole electrons. Yeah. Next step, to find out F. Yeah, the charge on the mole of the electron Faraday constant is Q divided by the mole. So the result, because we know the charge is 405. So we input 405 divided by this 0.004. So the answer is 97,200 coulomb per mole. That's it. Okay, any questions?
No.
This is the basic formula. How many formulas, sir? 1, and then 2, and then 3. Like that. Any questions?
No.
No? Diva?
No.
No, this is about electrolysis. We also have many more about organic compounds like alkenes, alcohol, and etc. There's also will be much theory to find out the main change, the branches, and etc.
Mm.
Yeah. Okay. If you don't have any questions, next, yeah. An accurate value of the Faraday constant is 96485 coulomb over mole. An accurate value of the charge on one electrons, like that. Use this value to calculate the value of the Avogadro constant to 5 significant figures. Okay, I will give you the basic theory. Yeah, what is Faraday constant? Faraday constant is to represent the total electrical charge carried by 1 mole of electrons. It is product of the elementary charge of a single electrons E, and also Avogadro constant. And then we symbolize it with Na. This is the formula, yeah? The formula is F equals E times Avogadro number. This is also related to stoichiometry. What is Avogadro number, sir? Avogadro number is what is the number of the particle for one molecules. Yeah. Okay, now back again in these questions. The Faraday constant, we know. So we input for Faraday constant F, that's mean Faraday constant is 96485 coulomb over mole. And then next, elementary charge. For elementary charge of an electrons E, this is you have to memorize, yeah, 1.602 times 10 to the power of negative 19 coulomb. So of course, I will highlight it. Of course, to calculate the Avogadro constant, to find out Na equals F divided by E. This is the basic formula. So you just input, yeah, 96485 coulomb per mole divided by 1.602 times 10 to the power of negative 19. So we get Avogadro number is 6.022 times 10 to the power of 23 over mole. Okay, so we get it. The value of the Avogadro constant. That's it. This is the basic, Diva. Okay, Diva, maybe next you can share to me the link ya. Maybe I can visit it so I can see what is the material of the chemistry from your school ya.
Oh,
Or maybe for the login, use your email ya sama your password, right? Or the email and the password from your school.
yeah.
Huh?
The what?
To get the material, Diva, should I use email and password to login or
Yeah.
what? Your email and your password or what? Or
Mm,
the email the school email.
no, my account. But
Oh,
it's not
your
related.
account.
Yeah, it's not related to my email.
Oh, and then is it okay if I use it or what?
But yeah, it's okay.
It's okay, yeah. Okay, maybe
Mm.
next you can share to me. Just only to maybe download or see what the topic and what is the material also from that.
Mm.
Okay. Mhm. This is the basic theory. So now you learn about the atom like in yeah. What is the nucleus? What is the electrons, protons, like that, or what? Only introducing about the ionic covalent compounds, or what, Diva?
The what?
Yeah, the topic, I mean,
Mm.
the topic of the chemistry in your school.
You only covered atomic structure for now.
Oh, on the atomic structure. I think atomic structure is the basic, yeah. Like ini kan, like atomic structures like disease, nucleus, ya.
Yeah, it's only that
Ya,
one first.
ya, disease kan, orbital. Ini mah easy. I think this is in grade
Yeah,
10, right? Itu mah
yeah.
just only, yeah, no. It's too easy lah. Like disease only 1 and 2.
I
Ya,
think
ini
it's just
disease.
a review.
This is consists of proton, ya
Mm-mm.
kan? And then neutron, and then this is electron. Ini mah tuh teori. I think you can read by yourself. But the challenging one like that.
Okay.
Apalagi in your grade 12. That will be
No,
hard.
I'm grade 11.
Yeah, maybe for next. Mm-mm. So, do you have plan to learn to study abroad
Yeah,
or in Indonesia, Diva?
abroad.
Abroad in what university?
Probably Malaysia or if I can, Australia or in the UK
Yeah, that's
or
better. So,
Netherlands.
yeah, I know. So you have to learn more and then you get a good score in your IB exam. So now you take IB high level or standard level?
A level.
Huh? Oh, A level. Okay, good. Yeah. Okay, Diva. So what is the name of your school, Diva?
Pribadi Bandung.
Oh, pribadi. Oh, so now you are, oh, Bandung.
Yeah.
Okay. Okay. Okay, Diva, maybe I will share my notes to admin, ya, admin IB. The
Mm-mm.
name is Kak Jesslyn. Yeah, I hope
Okay.
you enjoy my first class. Yeah, it's okay if you really uh not perfect. It's okay because kind of the process of the learning, yeah, is step by step. I think when you learn, repeat again, and then you can also continue to repeat the concept, you can get a good score in your exam. Okay, Diva, yeah, see you next time, yeah.
Yeah.
Bye-bye. God bless. Okay.
Bye.